The blue diode laser is great for engraving and cutting of the wood, and the infrared is great for engraving metals. Welcome to another laser engraver testing video. Ortur company sent me H20 for the testing, and I can keep the product, but I'm not paid anything to create this video. So this is not a sponsored video, there is no contract or there is no conditions for the video. I wouldn't even accept the review video if there would be any. Now, I already mentioned that I'm reducing the laser engraving videos on my channel, but I really like the Ortur's open frame engravers and I'm curious about its upgrade. Let's see a few specifications from the website. This is an enclosed printer with working area of 420 by 300 millimeters, and it has integrated camera, which is mandatory to supervise auto position or the printing. But interesting what is new, that it has auto edge detection. I'm not sure how it works so far, but this is used for the precise positioning of the engravings. Multi-light source supports. It can work with the blue lasers, which has the 450 nanometer wavelength. They are good for the cutting or engraving wood. And infrared, which has the wavelength of 1064 nanometers, and they are specially designed for engraving metals. Safe view cover, efficient ventilation. Optional, we can buy the Y-axis rotary unit for engraving cylindrical objects. It also has the dedicated app for easier using, which is great for beginners. Me personally, to be honest, I like to use the LightBurn or something similar where I have more control over the engraving, but I believe that beginner users really appreciate this app. And now a few words about the safety. Always I talk about that safety protection. You always have to wear the safety glasses, and everybody in that room should wear those safety glasses, but this is enclosed engraver. Then the second one is that you should use it in a good ventilated room, but this is enclosed and we can exhaust those fumes outside of the room or something like that. But of course you still have to supervise the engraving to avoid flames or something like that. I think the minimum recommended speed is 200 millimeters per minute to avoid catching the flame. But even then most of the parts are flame resistant, if I informed correctly. Let's see what's in the box. We have 3 smaller boxes, at least it was easier to take them out from the big main box. This is the base stand. And this is 2 watts infrared laser for engraving metals. I can see some serious fans here. Opening the next box. Oh, I think I need a bigger desk. In this box was the 20 watt blue diode laser module. I was hoping I will get the 40 watts so I can see its real possibilities. I can see the fans here on 2 sides, adjusting the height. And the third box is the top guard. And I think that's the camera and LED light inside. Exhaust pipe and adapter to handle those fumes. This is the X Gen 3 with the holder for the laser module. I can see a timing belt inside, but I cannot really see what kind of linear motion they are using here, but I can see it on the Y-axis. These are those V-slot wheels, and I'm not even sure what material are they made from. For the touch they are hard, maybe from some kind of metal. I'm analyzing it now because later it will be hard to see in. This is the Y-axis stepper motor and it has very long shafts, so 2 sides are connected. Another reason that I'm sad I didn't got the 40 watt version is that every time if I want to switch the modules, I have to move this plate and change the position of this limit screw. With the 40 watt version it would be in the same position like with the 2 watt infra module. I want to start with the blue laser and currently it is set to 40 watt version. So I have to move this screw and this plate. Now you can see what I was talking about. Every time I want to switch the modules, I have to move this limit plate, and to access to those 2 bolts which holds this plate, I have to remove this X Gen 3 too. Position of the handle. Installing the pipe flange, which will be held with 2 screws from the inside. In the assembling video there is no mention when to install the camera, but I will do it now because it's easier to access to it. And that is my first problem with assembling. Even if I tie these bolts, they don't hold. Theoretically it is tight. I mean, this is very thin bolt, I cannot tighten it too much and it goes into plastic, and look at this. This is M2 bolt, and theoretically it should go into this 1mm thick plastic plate. So I don't know who designed this, but definitely he is not a mechanical engineer. My solution will be 3M two-sided stick tape. Actually, aligning surface is here and here. This should work. I'm not sure for what size of the hands is this step designed, but this would be much easier to do if this plate wouldn't be here. In the assembling window, this plate is in lowest position, then we have enough space for these screws. I tried to lower it, but I'm not sure is it locked or what. I tried to move these belts, but it's not easy with my hand. Finally success. And this would be a very easy step if this would be in the lowest position. Connecting these screws from the top is definitely much easier. Beside these four, there are two bolts on the front side. Theoretically here I could connect the air assist pipe, and there is an instruction in that user manual assembling window. And then you can connect the air pump here on the back side. And I highly recommend using the air assist if you are planning some cutting of the wood. It is much nicer and also safer. But since my unit arrived without this equipment, I have to test it as it is now. This means without air assist. And the hardware installation is finished. In my case, this is just a temporary position of the engraver, so the end will not be connected to the window. The output is 24 volts and 6 amperes. These are typical materials I'm using for testing of the diode lasers. Different thickness of the plywood, hard MDF wood, stainless steel, black acrylic, anodized aluminum, and at the end we have some kind of documentation, something similar to this. That was the homing, and the fan was on maybe 1 minute, and after this it's completely quiet in the standby position. For setting the focus, we have to set this arm in this position, and then we can move the module by rotating this knob on the top. And if the height is not enough, then we can move this build surface. Only I'm missing some kind of limit switches in edge position. This was the upper position. In lowest position it stops correctly, it doesn't grind the belts. I'm starting with LaserGRBL, the COM port and baud rate is selected, and I can connect the engraver. And just quick test with these arrows. And it's working. This logo will be the first test object, vectorized lines, speed to 3000, dynamic power, laser strength to 60%, and size 20 by 20 millimeters. There's the framing, and it's a little bit hard to see the exact position of the laser without the camera. A good method in this case could be the toothpick method. I have a separate video about it, I will place the link down in the description. And it can work with this engraver too. This is real-time speed. Later this kind of footages will be speeded up. Because of the camera work I cannot wait, and I didn't use the exhaust fan. The settings are correct, but I think I have to play more with the hardware because I can see a lot of vibrations here. It's beeping because the cover is opened. Earlier engravers 2 or 3 years ago had that error that the mass point was very low, and with this, when it's moving fast, it has some vibration, and in this case, this could be the reason too. I will try to raise it in the highest possible position. This should be enough. Now the center of the mass is exactly on this support, but now I have to use some kind of support for this material too, because this is the maximal upper position for this workplace. Quiet, please. So much better than this one, but still far from perfect. I checked these 2 tightening screws on the back side. They were a little bit loose. They are tight now, so let's see one more time. This is the last attempt. And I can see still some kind of waves, not completely perfect. And last attempt with LaserGRBL, I lowered the speed and the power. And finally I have nice engravings. This is on 1K speed, but this was a little bit too strong on 30% power. This was also on 1K speed with 15% power, and this looks really nice now. Solution from this to this is to place the module in highest position and also reduce the speed. I'm moving to the LightBurn and I will do some cuttings too, so that's why I need some space below the object. Adding the device in the LightBurn, I'm just following the instructions on the Ortur's YouTube channel. Just search for the H20 LightBurn software. This software is great for testing because I can have lines with the different parameters. Here I will have two tests actually, and soon I will explain you why. This is the result of my engraving test, 60% line, 100% line from 1K to 6K speed. And if I have to choose between these, this one 3K on 60% looks the best, but if the graphics don't allow this kind of vibrations, in that case I have to lower the speed. So I have another test, 1000 and 1500 speeds, 10, 20 and 30%. Same here. And between these, this one looks the best, on 1500, 20%. And now the cutting test, but without external air assist. This is typical for 20 watt diode lasers, so you can cut this 3mm plywood up to 600 mm per minute speed. But I'm really missing that air assist. I can see some burn edges here. And this is the 800 from the opposite side. It was very close to be cut. I could even push it. And now let's move to the cutting of 5mm thick plywood. Focus reset. From 200 to 400 millimeters per minute. Let's see the other side. Oh. Okay. This is unexpected from 20 watt diode laser. Let's see two more speeds. Strong 20 watt diode laser, it can cut this 5mm plywood even on 500 millimeters per minute speed. 600 close, maybe I can push it out, but yeah. Now one thing I don't like, these burn edges, and that's because of the missing air assist. So if you plan to use this a lot for the cutting of the wood, then definitely I will suggest you to use some external air assist too. You will have much nicer cuttings. And now cutting of this 3mm MDF wood. These are cutting speeds, and actually this on 300 is not bad. The cutout part is quite clean, but here I can see some burn edges. Let's see this 400. Probably I can push it out. Yes. 3mm thick black acrylic, and usually the settings here are similar to this MDF wood. I hope positioning will be accurate because I don't want to burn these boxes. It is hard to see the spot during the framing. I'm using this piece of paper for framing, later I will remove it. (300, 400 millimeters per second speed, and it looks like it likes better cutting of the wood. Probably this should be cutting on 200 millimeters per minute speed. And this time it is cutting out, and really nice and sharp edges I can see here. Anodized aluminum, and actually this is very easy for the engraving because it is not sensitive to settings, it will not burn and similar. I think I did a mistake that I didn't start with setting the camera, because it is hard to do the positioning on this kind of materials. This is real-time speed, and this engraving will take a little bit more than 3 minutes. It was 3.5 minutes. Not exactly what I expected. This plate is too thin and it warped a lot, and it touched the module, that's why it moved. But looks like the settings are not correct neither. Usually I'm using this kind of plates which are almost 1 mm thick compared to this one, so let's do a second attempt. Again, real-time speed, and this engraving will take half minutes approximately. Yes, this is what I was talking about. From 2000 up to 10,000 millimeters per minute speed, each of them looks great, even the fill or the outline. Only depend if you want to avoid those waves, then you should slow down. And this is not a sponsored advertising, but I highly recommend the Churboka tags. I really like these materials because they are very easy to work with them. And now engraving on this stainless steel, I want to try the line and fill engravings. The line engraving will be on 400 millimeters per minute, and the fill will be on 800. Here you can see the settings. And this engraving will be less than 30 seconds. At the first look strong engraving, let's clean it with isopropyl alcohol. 400-800 millimeters per minute speed, and I can feel that especially this line art is quite deep. I hope you can hear that. And now something which actually I should start with, and that's setting the camera. It uses a separate USB cable which is connected to my laptop. And now let's do the calibration. It requires 2 steps. And the first one is the calibration of the camera lens. And the second is the camera alignment, and I'm using these paper sheets for this. Speed is 3000 and 20% the power. It will engrave these 4 points, and the next step I have to click on these points through the camera and on the laptop. And the camera calibration is finished. Just a quick test, let's try to engrave a circle in these squares. Updating the camera overlay, I can preview the position of the graphics. And typical accuracy of this method is approximately 1 or 2 millimeters, and closer to the center it is always more accurate. Until I'm familiar with the blue dyed laser, I have no experience with this infrared, but according to the Ortur, it is designed for the metal, and I want to test it with the stainless steel, raw aluminum and brass. Replacing the module itself, it is extremely fast. Only it's pity that this is not 40 watt dyed laser. In that case I don't have to move this limit plate and the screw. This means instead of 1, I need 4 minutes to switch the modules. Let's see what can it do on the stainless steel, and I will compare the engraving to this one. Setting the focus. And since I switched the module and they have different size, I have to change the work area in the LightBurn. If this would be 40 watt dyed laser, in that case no changes are needed. I just started a little bit with experimenting. An important thing to remember, set the focus correctly. These are exactly the same parameters, but this is maybe 1.5 millimeters higher. And this is the correct focus, and actually all these are quite deep engravings. And look how thin is this engraving compared to this one. And I'll try to engrave exactly this using the same parameters like with the blue laser. This is real-time speed using the same parameters like with the blue dyed laser. Let's clean it. So as I mentioned, I use here exactly same parameters like with the blue dyed laser, and for the filling they are both equally deep. Maybe this one is even deeper. Only it looks lighter. This is because it is thinner and sharper line, and probably this is good for the, I don't know, grayscale images or something like that. Now the reason we are able to engrave stainless steel even with the blue dyed laser is that the steel has a weaker thermal conductivity, unlike brass or aluminum. This means if we heat up one small spot, it will melt there. Let's see if a smaller, thinner line will help with engraving, I know, brass and aluminum. And this is real-time speed engraving the last square. And look at this, engraving is really there, and I can feel that it is deep. Only lines are very thin. Let's try to engrave a filled circle. This is real-time speed. And this is something what we cannot do with the blue dyed laser, and it's not coming down. And for this engraving, it's lighter. I increased the line distance, but it is also visible and it's permanent. I cannot scratch it down. Let's see if we can do something on the brass. These are the settings, and I'm using the fill option here. New focus set. And really it can engrave your brass too, and this is not coming down either, and I can feel that it has some depth in the surface. Overall conclusions. Compared to the open frame engravers, this is better because it is enclosed, theoretically safer, and we can exhaust those fumes. Now, if you have a dedicated space for it, then definitely this is a better solution compared to the open frame engravers. But those engravers have the advantage too. For example, for me it's not a problem to wear a safety glasses. I'm the only one who is in that workshop. And also it's not a problem to ventilate the room after the using. And after the engraving, it requires much less space because those open frame engravers can be stored vertically. So I suggest you to buy something like this if you have a dedicated space for it. Few words about this 20 watt diode module. The strength is average like any other 20 watt diode laser I tested so far. For the wood, this is even a little bit stronger. For the black acrylic, this was a slightly weaker, so basically overall it is average. I don't really like its mounting. I think it should be more rigid. You saw that vibrating if it is in too low position. And if you want to have both modules, I would suggest you to buy the 40 watt version if possible. In that case, if you switch between the modules, you don't have to move those limit screws and plates, and switch can be done in less than 1 minute. And also, if you are planning to cut a lot of woods, in that case I would suggest you to buy external air assist pump. In that case those cuttings will be much nicer and you will get much sharper edges without those burnings. About the 2 watt version, this is my first infrared laser and I don't have experience with it, but I'm very happy that I can engrave metals too. Because with blue diode laser I could engrave stainless steel, but no chance to have any kind of success with aluminum or brass. And my settings are still not final, I have to experiment with it more, but for this video this is enough. And if you have some other experience, few lines down in the comment section. Thank you for watching and happy and safe engraving.